During a development project, a number of engineering issues will need to be considered. We're now going to be speaking with John Goldfinch from FMG Engineering to step us through what some of these considerations are. John, thanks so much for making the time to speak with us today. I know you're busy. To get things started, can you tell us a bit about yourself?
I graduated as a civil engineer back in the end of 1972 and commenced work in February 73. So I've had a fair few years' experience of looking at Adelaide soils, construction techniques, and of course our notoriously bad Bay of Biscay type soils. The predominance of what we call Bay of Biscay soils are in the eastern and northern suburbs, but they also extend well down south through Shido Park, Trott Park, Woodcroft, Ranella and places like that. And they're also found in country areas, and they're found all around Australia.
What are the constituents of this soil?
These are what we call reactive clays. That's their correct classification. Are very fine-grained soils, and they react with water, and that's where the term reactive comes from. So that when they absorb moisture and go from a drier to a wetter state, they tend to swell and cause upheaval of structures. And conversely, if we start off with a wet site, then it dries out, we will get a volumetric shrinkage of the soil, and we tend to get settlements of structures. And you start seeing the cracking come in because corners drop and elevations drop, and we get cracks at ceiling cornices between the cornices and the walls. Those sorts of soils, unfortunately, are most acute in Adelaide, with respect to the whole of Australia, but there is reactivity in clay soils throughout the other states of Australia, even in Perth, where there's a lot of sand. East of the airport there is some clays, and they are just sort of running into the problems as they develop further out. So they also, those sorts of clays, affect other countries in the world. There is Johannesburg in South Africa, Colorado in the United States, and a few other areas, Southern California. There's some provinces in Canada, there's Jordan, Israel, throughout the Middle East, but they occur sporadically and create problems for building.
And I guess that's where the engineering comes into it, isn't it?
Yes, exactly.
Okay.
Exactly, because we need to be able to design footings for these reactive foundations, and that's the way around that the engineers put it. The layperson will often talk about foundations, referring to the concrete support medium for their house, but the correct terminology is that that's a footing, and the foundation is the soil.
Okay. John, I've heard of some people getting a bit carried away in regards to the footing issues. Can you tell us a bit about that?
Yes, certainly. That's something I do run into every day, either over the telephone or in the field. In the Australian Standard 2870, in its Appendix C, there's a table C1 that rates cracks in walls, and a table C2 that rates cracks in concrete floors. Now, with respect to the cracks in the concrete floors, almost as surely as concrete is delivered to a site to cast a footing or a slab, you will get shrinkage cracking. Concrete's made of water. Some of the water is used in the hydration reaction or the setting process of the concrete, but the remainder of the water progressively evaporates out of the mix, and hence your hardened concrete is always going to occupy a smaller volume. So we get shrinkage, and we would all like to think that that shrinkage is uniform and just diminishes the overall size of our slab or our building. It doesn't quite work that way. Any amount of restraint to the shrinkage, and it may just be the friction of the soil underneath a slab or underneath a polythene layer under a slab, will create some level of shrinkage cracking. Hopefully a large number of very small cracks that are infinitesimal and we can barely see them, but more often than not we get a random pattern of cracking, like in the shape of a letter Y, branched cracking, purely caused by shrinkage. It is not a structural failure, in spite of what some people think. It is a normal function of concrete, and it is controllable in part by making sure that the steel reinforcement is placed in accordance with the engineer's recommendations in the footing construction report. And if we do all of that, we've got the best possible chance. Pardon me. Now, if we turn to wall and ceiling cracking, that's table C1, and there are categories. Now, category 0 to 1 cracking, from my recollection, it cracks up to about 1.5 millimetres in width. And if you've got an easily repaired structure, such as, for example, a masonry veneer on timber or a masonry veneer on a steel frame, the normal lightweight type construction that is in very common use today, then you can have a 50% excess on that 1.5 millimetres. And the Australian Standard 2870, in its appendices A and B, actually mentions that it's quite normal to get cracking in that category of 0 to 1, and not to worry about it because it's easily repaired and maybe even non-structural. It could be caused by materials related shrinkages, such as shrinkage of concrete floors, shrinkage of timber wall frames, and perhaps a little bit of expansion of clay bricks, or even shrinkage of concrete bricks. So there's a few forces in the materials that are used in a house that oppose one another, that are going to sometimes create a little bit of movement cracking. It usually occurs within the first 5 years after completion of construction and after the establishment of landscaping and gardens, because that's when people might convert an otherwise broadacre site into suburbia, when we start planting lawns, gardens, paths, retaining walls go in. So the whole site moisture characteristics change at that time. But if we give that about 5 years to settle down, by and large, and in the greater majority of cases, the cracking and movement also settles down. And it's prudent to repair it probably just before the 5 years is up, because that's the statutory warranty period in the state of South Australia under the Building Work Contractors Act 1995. So builders do have that obligation to come back and assist with that sort of minor repair work within the first 5 years.
Okay, I guess after that 5 years, then the other thing to consider is being careful to remove very large trees next to the house, because that could also change the moisture content around the house, which could affect the...
Absolutely, absolutely. And to that extent, because we now have statutory watering restrictions in many states of Australia, and we're very short of water, we can't water our gardens like we used to, and that of course upsets the equilibrium or balance of soil moisture around our suburban dwellings, so that one neighbour affects another neighbour that affects eventually the whole neighbourhood, because a moisture deficit is occurring in our soils. And as I've already said to you, with clay soils, that moisture deficit means that we're going to get a shrinkage of the soil, and that means that corners of our houses start to drop, we start to see diagonal cracks coming, we start to see cracks between ceiling cornices and wall faces, we start to see rotation of external walls, and the degree of severity of that is greatly affected by trees. Tree roots can, and do quite often, extract significant volumes of soil moisture, just pulling it out of the pore spaces between the soil grains, and therefore these grains sort of roll together and interlock to form a lesser volume, don't they? Because some of the moisture holding the grains apart is actually being used by the tree. And we find that in the direction of clumps or rows of trees, that those are the corners of the houses we see with the most severe cracking. And of course even street trees can cause that to happen.
So I guess from a developer's perspective, they can get an engineer in, they can engineer a house to the best possible standard, but just to keep in mind where you're going to be putting your trees, where you're going to be putting things that will change the moisture content around the house.
Yes, And as a general rule of thumb, engineers will have in their footing construction reports advice on gardens and tree planting.
Good.
And we will be saying to people, look, if you're contemplating planting a tree, make sure that you position it at least 1.5, maybe 2 times the mature height of the tree. Not as height as a sapling, the mature height of the tree, away from any structure.
Good.
Otherwise it's highly likely to cause damage.
Yep.
And when removing a tree, a similar thing can happen. So if you come to a building site that you've selected and you're allowed by council and planning regulations to remove some of those trees, then you've got to be very careful to pre-wet the site to restore the balance of moisture in the area from where you've removed those trees, because the clay soil in those areas will be particularly desiccated.
What kind of time period are you talking about here, John?
Well, we're all in a rush to develop things. What we like to do is leave a crater in the soil from where the tree's been removed, and for at least the time up until footings construction is contemplated, to maintain that crater with moisture in it.
Okay.
To feed water into it, and that will be absorbed or sucked into the clay soil, and at least, even if it's only in part, restore the moisture balance. And that gives the footing construction and the house construction a much better chance of not undergoing quite a significant heave in the first 5 years in the area near where that tree was removed.
Okay.
With respect to the salinity of the soils around Adelaide and the Greater Adelaide metropolitan area, the fact is that our paleogeography tells us that at one stage salt water extended right up to the foot of the Mount Lofty Ranges. We actually didn't have gulfs. They were formed later during a period of aridity. And these shallow saltwater lakes, of course, picked up sediments blowing down from the north, the very fine dust sediments. They settled to the bottom of this lake, and the pressure of the overlying water consolidated them, and then they got additional or over-consolidated as the water receded and the gulfs were formed, and the arid climate that we used to have in South Australia actually baked these clay pans and really compacted the soils and made them very much over-consolidated. So they're very fine-grained, they're over-consolidated, and they contain salts. Now, the degree of reactivity is enhanced because of the salinity of our soils, the high salinity levels of our soils, and therefore we tend to get the greatest reactivity in our clay when they wet up, because these salts leach down the profile a bit, causes the soils to expand in a much worse manner than they otherwise would. So we have a phenomenon known as salt damp in South Australia, that elsewhere in the world and even interstate it's referred to as rising dampness. Now, in the state of South Australia, if you hear the term rising dampness or salt damp, they're basically synonymous terms, because one equals the other, quite frankly. And what happens is saline moisture enters porous building materials like bricks or stone or mortar or concrete, and when the saline solution, the water evaporates from it after it's entered our porous building materials, and it leaves behind a concentration of salts in the near surface of these materials. And what happens to those little salt crystals is that from their anhydrous state to their fully hydrated state, as they take in water molecules, they expand. And that expansion is actually what causes the exfoliation of the front face of our materials. So you could walk up to a brick and it will be powdery, and you can remove the powder with your hand or with car keys. Or the mortar might be falling to bits or eroding out of the mortar joints. In the case of concrete, you'll see the outside face of the concrete dropping off and leaving a little pile of debris on the pathways. So that It's very much a surface attack working its way in. It's not like termite attack in timber, where the termites will actually eat the inside of a timber member out and leave the paint. Salt damp is exactly the reverse. It works from the surface and works its way in. But if there is a good aspect to it, what you see is the worst you've got. And it is treatable.
Yep, and the remedies would be something like damp course.
Absolutely. We've learnt in South Australia virtually to encapsulate all of the concrete that we pour in the ground in polythene sheeting, in prescribed 0.2 millimetre thickness underlay, commonly seen to the layperson as orange plastic on building sites. And we cast our concrete in that so that we don't have contact between the saline soils and the concrete itself. One of the most interesting problems that's become very prevalent today is paving around houses, because we're finding that there's this slab edge dampness attack that occurs, and the salts attack the outside face of the edge beam footings. Now, to prevent that from happening, in the same way that we put a horizontal polythene damp-proof course in to stop rising damp from getting into our walls, we put a vertical polythene membrane in to prevent the horizontal transfer of dampness across from the sand we might have laid our paving on and the paving bricks or blocks themselves, or even solid concrete paving. We've got to stop the transfer of dampness from one piece of concrete or building material into the other, and we do that by simply putting in a vertical membrane of polythene. But the number of times I see that left out is absolutely staggering.
Okay.
And it can create problems.
Okay. John, you certainly have a fair bit of experience in engineering. Can you run through for us and for the viewers various things that they'll need to consider from an engineering perspective when building a house?
Certainly. Well, one of the simplest things really is that a surprising number of people perhaps start off purchasing an allotment but don't know that there might be easements or encumbrances on the allotment. And if you, for example, were buying an allotment on the low side of a road so that you didn't have drainage by natural gravity, then you might like to find out that there's an easement at the back that you can put your stormwater into, connect into your stormwater. And that would make life a lot easier. The other thing we notice about sloping sites, whether they be on the low side of the road or the high side of the road, is people forget about the cost of retaining walls. And retaining walls can be exceptionally expensive, and if overlooked, that cost can be quite crippling for a homeowner when council say, look, you have to retain that site because you've cut more than 600 millimetres on a boundary, or you want to put more than 200 millimetres of filling on a boundary.
What costs could they be looking at?
Well, you could be looking at costs of around $900 a metre, $1,000 a metre. That's a linear metre to build them. If you've got a steeply sloping allotment, you can be up for retaining walls of the order of 2 metres high or even higher than that. You might be undermining your neighbour's property, or you might be undermining and causing loss of stability of any structures on the neighbours' properties. So you do have to be very, very careful when you're looking at sloping land and get architectural and engineering advice about how to manage it. Now, what we've also found over many years of looking at building problems is that even if retaining walls are built, people tend to either leave out or not put in the correct position agricultural drains. Now, that's a fancy term that's used for a drain with slot holes in it, and those slots or holes pick up groundwater or surface water that percolates down behind the retaining wall and can convey it away, so that we don't add water pressure to the soil pressure bearing on the back of the wall. And they are very important, and it's very important to install those drains correctly. Sometimes people forget that on very steeply sloping sites they may own a very low motor vehicle like a Porsche or something like that, and it's not too good if you finish building your house and then you go to put your car in the garage and whoops, you hit the curb and gutter as you're trying to get down your very steeply sloping driveway. So driveway gradients and slopes of sites and contour survey plans are required and need to be looked at by engineers when you're planning a house. Some of the other issues that become important are whether or not the house is being built in a bushfire-prone zone and what level of risk there might be. Information on that can be obtained from the Planning SA website of the South Australian Government. We've also got the situation that if, for example, a sloping site was purchased where it slopes away from the road and there wasn't any rear of allotment easement to pick up drainage water, you may have to consider a sump and pump system to lift that water up and pump it back to the road level. And those sorts of costs often get overlooked, and those sorts of problems often get overlooked.
Is that also a case when building more than 3 dwellings?
Oh, absolutely. Yeah, row houses or the 2-storey townhouse type construction, any site that's being considerably infilled and has a lot of runoff stormwater, we've either got to collect it and retain it on the site in tanks, which are becoming more prevalent today because of our water shortage. If we get an excess of stormwater on our site, though, and we've got to get rid of it, then we may have to pump it up to road level if we haven't got an easement so that it can drain away by gravity.
So this is another cost consideration for a developer that's considering putting in multiple
Absolutely.
property.
Absolutely. And in thinking very carefully about site selection.
Yeah.
Okay. The issue with respect to cutting and filling on a site, and hence the building of retaining walls, is that our legislation for building is governed by the Development Act 1993 and the Development Regulations 1993. Now, in that Act and those regulations, we're allowed to cut on a boundary 600 millimetres vertically down and thereafter at a sloping plane of 1 vertical to 2 horizontal, and that's permitted by law, by that Act. But when it comes to filling, and this is one that catches a lot of people out, we're only allowed to fill to a depth of 200 millimetres on a common boundary within 600 millimetres of that boundary. And even then, that fill soil has to be for gardening, landscaping or the like. So you can't build on that, and 200 millimetres is not very much soil. So, for example, people put it against a corrugated iron fence, and there's not a problem with that because they're allowed to by law, by those acts. But as soon as the fill soil depth exceeds 200 millimetres, then proper retention by a retaining wall is required.
And I would suspect that for a developer, this is another consideration with site selection.
Absolutely, and the retaining wall situation is that wherever a retaining wall is in excess of 1 metre high, it's got to be council approved. We can't use the landscapers' walls, as I'll call them, where we get these split face fancy stones and blocks that are made these days, concrete blocks that are made to build garden retaining walls. They're okay, but you can't exceed 1 metre in height without council approval. Also, a fact that is often overlooked by developers is the fact that as soon as you have a change in level, either inside a home or in the landscaping of a site of 1 metre or more, you must balustrade it, or you must have a fence on it. You must stop people from having the capacity to fall over it, fall off of it. And that's something that catches a lot of people out, and it's quite easy to do. 1 metre is not very high. You might build a garden retaining wall on a sloping site across the rear of your yard as part of the landscaping, and as soon as it gets to 1 metre, then you have to start thinking about some form of balustrade or fence on it. The other sorts of issues are whether or not you've got any idea of what the soil conditions are like when you're selecting a site. Some guidance for this can be obtained by studying soils maps. Now, I wouldn't expect the average developer to know where to get hold of these soil maps, but any geotechnical or civil engineers usually have them in their office, and it is possible to just have a rudimentary check of those soil maps to get some idea of what the reactivity of the soil might be like in any particular area. And indeed, most engineers have staff that are experienced enough to be able to tell a developer what the likely reactivity of the site would be.
From a cost perspective, if you took the average house and you built it on a soil that was non-reactive, and then took that exact same house and built it on a soil that was highly reactive, what could the cost difference be in foundations?
It could be of the order of $8,000-$10,000, something like that, because there is a significant penalty when you're going on to the higher reactive clays. And I should have mentioned that clays do have grades of reactivity. We start off, if we look at the Australian Standard 2870, which is the standard for residential slabs and footings construction, section 2 of that document says that we can have an A site, a class A site, which is a very stable site. Very few of them in South Australia, less than 5% of sites. We can have an S site, which is a stable, maybe have a little bit of clay in it, but it's a stable site. We can have an M site, which stands for moderately reactive. We can have an H site, which is highly reactive, and we then step up to the really big guns and get to the E sites, the extremely reactive sites. And in South Australia, because we have deep-seated clay profiles, they all have a D rating, which means deep-seated clay. So we have H-D, we have E-D, and M-D. And we have a range of footings, basic footings, that can be looked at in that code to get some idea of the size of footing that might be required for a particular type of structure. I think sometimes it pays if people are looking at a site, particularly for a major development, which may be multiple two-storey townhouse type residences, or perhaps a retirement village or something of that nature. It would really pay to get what we call a preliminary footing report from a geotechnical engineering firm. Now, the reason for that is that it will give an idea of the soil movement characteristics of the site. It will classify the soil at the site. It will give some suggested footing types and sizes for preliminary costing purposes. It will get a contour plan of the site if one hasn't already been drawn, so that in the future, after final architectural plans are decided upon, we can obtain them and then convert that preliminary soil and footing report into what we call a footing construction report. And that is a document that is used for development approval to get provisional building rules consent for the footing design. It must be a footing construction report. It can't be a preliminary soil report. But the preliminary soil report has its place, as I said, for particularly major or large developments, to get some idea of the site and what its complexities might be. Contour plans are necessary for engineers because it is from those contour plans that we develop a site drainage scheme. We know that we drain as much water as we can by gravity, and hopefully all of it by gravity, and sometimes with a sump and pumping system. That's why a contour plan is very handy and very necessary. I think that other issues that may come up with a developer, and particularly an owner-builder style developer, is the requirement to build strictly in accordance with the council-approved plans, technical details and specifications. Now that is defined in section 45, 1 in brackets and 2 in brackets in the Development Act 1993. And it actually says that a person, and that's the interesting word, a person, and that takes in the owner-builder. It doesn't say a licensed person, which means it doesn't refer just to licensed builders or licensed works supervisors. It refers to an owner-builder as well. And that means that if somebody is working in the capacity of an owner-builder when building Class 1 domestic residences, they do have a legal obligation not to cut corners and to do it exactly in accordance with the approved plans and species from the Council's development approval. So that's the reason why any development approval has two parts: the provisional planning rules consent and the provisional building rules consent. And engineers are mostly concerned with the provisional building rules consent. Also, another little pitfall, again particularly for the owner-builder, is that a section 83 capital A capital B statement of compliance has to be issued at the completion of building works. Now that's a certificate that goes to council to say and certify that the dwelling has been built strictly in accordance with all of the approved plans, technical details and specifications that were part of the development approval issued by council. Minor variations, of course, are allowed, preferably if they're in writing.
This assists with the 5-year warranty as well?
Absolutely. And it assists in having all of the documentation kept nice and tight, as I'll call it, so that council are put in the best position and the owner and owner-builder or builder are put in the best possible position. Because the builder will seek a statement from his electrician and he'll seek a statement from his plumber to say that they have wired the home up and plumbed it, respectively, in accordance with their codes of practice. So it's a very important statement. Again, it's often overlooked, and councils are increasingly enforcing the provision of that at the completion of building works. It's particularly important that owner-builders understand that in order to obtain that section 83AB statement of compliance, they must have their work looked at by either a licensed builder or a licensed works supervisor during its construction. In other words, there's little point in finishing the dwelling off and then calling up a professional and saying, oh, can you just certify that this complies with plans and specifications? Because we can't see behind internal linings. These inspections have to be conducted before ceiling linings are put up and before wall linings are put up. Things like wall bracing have to be looked at, roof framing and bracing has to be looked at, roof tie down and anchorage has to be looked at, and wall frame anchorage has to be looked at. Similarly, before you pour concrete in the footings, they have to be looked at to make sure that the steel reinforcement and the size of the footing is adequate and in accordance with the engineer's design. And that's the only way a professional can sign off a section 83AB.
Okay. This certainly isn't only applicable to South Australia, this is nationwide.
I suspect it is, although building legislation or the calling up of the building rules via the Building Code of Australia is state-based, which is quite curious, isn't it, really? Because we have our Development Act 1993 and our Development Regulations 1993. The New South Wales people have what they call Ordinance 70. The people in Queensland have the Building Act 1975 as amended, and so on and so forth in the other states, which I haven't researched. But essentially, the individual state legislation that calls up the building rules in any state can be marginally different. And I'm not aware of whether or not the other states have the Section 83AB statement. But they would have something very similar, I'm quite sure.
I guess that's up to the developer to look into.
Absolutely. But it's very important and it's often overlooked. Some of the other, what I'll call miscellaneous building details that are not considered or overlooked by developers is an awareness that non-masonry fences in excess of 2 metres in height require council approval, development approval. Masonry fences in excess of 1 metre height require development approval from council, and the design of the fence would normally be done by a structural engineer.
And again, this may vary across the various other states?
It may, because that is in our own legislation. Yes, that's in the development regulations, which is a state-based set of regulations in South Australia. As I've said before, retaining walls in excess of 1 metre height require development approval. Paving up against the outside edge of concrete footings must have a vertical separating polythene layer, or we'll end up with this slab edge dampness phenomenon of getting salt damp in the edges of footings. The details for placing pavements adjacent dwelling footings are usually contained in an engineer's footing construction report, in the notes or sketch details that are provided with that. And it's most important that owners and owner builders read the engineer's footing report from cover to cover, so that they pick up on all of the standard details that are shown in there, because again, harking back in South Australia to section 45(1) and 2 of the Development Act 1993, they have an obligation as a person to build in accordance with the approved plans and specifications. Termite treatments, I should mention. There's an Australian standard 3660 part 1 is for new dwellings, the treatment of new dwellings. It can be done by combining more than one management method, and for existing buildings 3660 part 2 sets out requirements for maintenance treatment to contain termite attack and identify it. So all in all, it's a bit of a complex pathway, but somehow we all seem to get there at the end of the day.
Okay. John, we've spoken a lot about soils and a lot about retaining walls as well. What about the actual structure of the house, particularly when a house has been architecturally designed? How would an engineer come into that, I guess, in the way of looking at, say, beams, supporting beams, etc.?
Certainly. Well, a structural engineer needs to estimate the loading on any such beams, lintel beams, roof pitching beams, supplementary support beams for floors, columns, posts, anything that might be load bearing in a structure, including its walls, ought to be looked at by a structural engineer, particularly if it's a quite complex split level residence that's been designed. Engineers are able to assist architects in making a structure strong enough and stiff enough to resist the statutory loads that our Australian standard loading codes apply to those aspects of a building. So in general terms, I've always looked at it that the architect makes them look pretty, and we've got to make them stand up.
Yep. And I guess that's another cost consideration as well, isn't it?
Absolutely, yes. Engineering fees are incurred, and of course just simply the cost of beams and columns and steel and timber in this day and age. A lot of carpets and slabs are ruined by this slab edge dampness, this salt damp attack that's been attacking through the edges of concrete footings.
Yeah.
We've seen a lot of roof problems with nail plate trusses and a particular type of nail plate.
Yeah.
They've been squeezed out of the timber, and in some cases literally falling off the timber, and that's the only connector that the various pieces of timber in the truss have, one to the other. So we've seen some sagging roofs and near collapses. We've seen the syndrome of what we call a roller door syndrome, where in garages the top of a roller door has some clearance when the door's closed particularly, and wind-driven rain whips in there in storms and wets about the first 2 metres of the plasterboard ceiling in a garage, and of course that absorbs the moisture because it's a gypsum plaster and gets heavier and then starts to sag, and eventually we've seen them collapse. We've seen them come down, brings garage ceilings down. So they're the sorts of damage that we see on a fairly regular basis, strangely enough. We see the occasional full ceiling collapse, which has pulled all of the fixing clouts out of the old timber members, which have shrunk. What else do we see? We see, still see a little bit of blistering of the new age acrylic coatings that go on walls, and that's because if moisture's getting into the background wall and it can't get out through the impervious nature of the acrylic texture coating, you'll get blistering, and the blisters eventually burst because the water vapour that gets inside the blister expands to the point that the acrylic, just as it progressively loses its elasticity, will be breached, and then of course the texture coat can fall off and leave big open, like wounds, if you like.
So it'd be fair to say then that if a dwelling was correctly engineered and built, a lot of this stuff shouldn't happen.
That's very true, save and except for the situation of steel nail plates being squeezed out of timber trusses, timber roof trusses. Technology changes almost on a daily and certainly on a weekly and monthly basis. We get newer and better products all the time, but until some products have been in production and in use and in practice for a number of years, we don't know what problems might be hidden there, or latent problems as we call them. So in the case of the nail plates, nobody knew that the particular type of nail plate that's giving problems, which is no longer produced incidentally, would give us the problems that we're encountering now. But there's certainly a lot of repair work going on in roof spaces as a consequence of that.
Great. John, once again, thanks so much for making the time to speak with us today.
You're welcome.